I welcome to all on the course of Refrigeration and Air Conditioning. I am Prabhupada Senapati, lecturer in Mechanical Department. Now, in this video, I will cover the heat rejection factor and water-cooled condenser and types of water-cooled condenser. Let's start from the heat rejection factor. As I know, in the condenser, the heat is rejected to the cooling medium. So, in the condenser, you are calculating the heat rejection factor or heat rejection ratio. So, it is the heat rejection ratio is defined as the load on the condenser per unit refrigeration capacity. So, the load on the condenser is denoted by QC, and the load on the condenser, that is the summation of refrigeration capacity plus work done by the compressor. So we can write mathematically QC is equal to RE plus W. So heat rejection factor we can write in the short form HRA. So HRA we can write the condenser load QC by refrigeration capacity RE. So QC is equal to RE plus W by RE. So if you partially divide, then you will get 1 plus W by RE. We know that COP is equal to refrigeration effect by work done. Then this is the W by RE, so we can write 1 plus 1 by COP. So the heat rejection factor is equal to 1 plus 1 by COP. Here you observe the heat rejection factor depends upon the coefficient of performance, and the coefficient of performance which depend upon the evaporator and the condenser temperature. So here you confirm that the heat rejection factor is also depend upon the evaporator temperature as well as the condenser temperature. Let's come to the water-cooled condenser. Just now you have completed the air-cooled condenser where the cooling medium is air. So the water-cooled condenser uses the water as a cooling medium, and that water may be recirculated or the fresh water depend upon the availability. This water-cooled condenser is more efficient than the air condenser because the water has more capacity, more heat carrying capacity. It will absorb more heat than the air. For that reason, the water-cooled condenser is more efficient than the other type condenser like air condenser. But the water-cooled condenser regular service and the maintenance is required. And also to store the water, the cooling tower is required. And to prevent the corrosion and the forming of algae, the water-cooled condenser requires constant supply of makeup water along with water treatment. Otherwise, the corrosion and algae will be fermented inside the tube. So, water-cooled condenser depends upon the cooling load in the evaporator and the condenser temperature, and availability of water and water inlet and the outlet temperature. This type of condenser are commonly used in the commercial and industrial refrigeration unit. So, the water-cooled condenser varying in construction in three ways. The types of water-cooled condenser in three ways. Mainly three types of condenser. One is cell and tube type condenser, cell and coil type condenser, and tube type condenser. Let's start from the cell and tube type condenser. So, cell and tube type condenser, first you come to different parts of this cell and tube type condenser. Here you observe these are the tubes through which water will flow through it, and I'll show you the actual cell and tube type condenser. This is the actual diagram, and here the water inlet, and here is the water outlet, and this is the water inlet, and this is the outlet. Water in and water out, and this is the refrigeration from the evaporator that will be in, and the refrigerant out here. Here refrigerant in and here refrigerant out. Let's come the detailed view of the both parts. Here I am showing you four diagram. In the first diagram, I open the lead part. Here knot bolt joint is there. I open this knot and bolt, and it will look like. Here you observe here the inlet of water, and this is the outlet of water, and generally this is the cold water and this is the hot water. And this is the baffle which is separate the hot water and the cold water. And these are the tubes. These are the tubes through which water will be circulated. This is the left side. And come to the right side part. In the right side part, if you open the nut bolt, it's like totally different. Here baffle is there, and here there is no baffle. Here water will be in and water will be strike here. As the water will be strike, again it will be come up and pass through the upper surface. Upper surface, then it will be left out here. To separate two things, you are using the baffle. So this is about the construction. Let's come to the working principle. In this type of condenser, the hot vapor refrigerant enter at the top of the cell and condense as it comes in contact with the water tubes. The condensed liquid refrigerant drops to the bottom of the cell, which is often served as a receiver. However, if the maximum storage capacity for the liquid refrigerant is less than the total charge of the system, then the receiver adequate the capacity as to add it in case of pump down facility is to provide in the ice plant or the cold storage. And in some condenser, extra rows of water tubes are provided at the lower end of the condenser for subcooling of refrigerant below the condensing temperature. So, this is the working principle of this cell and tube type condenser. And here is the animation also. You are observing same thing. Here is water passing through the tubes and from the left to right, and it will strike and it again return to the upper surface. And here water is out. And here the refrigerant in, and here is the refrigerant condense and is converted to the vapor to liquid. Same thing here also I am showing to you. The coolant in means water in and the water out, and here is the refrigerant in and the refrigerant out. So this is all about the cell and tube type condenser. Thank you.